Okay, proposition 44 says, to a given straight line to apply in a given rectilineal angle a parallelogram equal to a given triangle. Right, so this one is similar to prop, what was it, 42? Yeah, 42, which was also about being given a triangle and an angle and creating a parallelogram within that angle equal to the triangle. So this is similar, but the only difference is the extra constraint is that we're being given a line segment, AB, and this line segment has to be one of the sides of the parallelogram, which contains or is contained in angle D and is equal in area to the triangle C. So it's sort of just like an extra constraint that gets tossed on there. And I've done a little bit of background work already. So obviously here's the triangle C that we're given, here's the angle D that we're given, and assume that we're given this line segment AB. I've already done a little bit of work. It's just like the first few steps, just so that so that I could get a little bit of extra precision in here in my diagram, and two, so that the video didn't turn out to be like super long. Because the very first step says, let the parallelogram BEFG be constructed equal to the triangle C in the angle EBG, which is equal to D. Let it be placed so that BE is in a straight line with AB. So that's pretty much all of this business, is so that, right, here's BE in a straight line with AB. Angle EBG is angle D. And then BEFG is equal to triangle C by prop 42. So that's just the background that I did there. So I'll write that step. I have to save myself a little bit of room because this diagram will expand. Let's see, I'll say, and this is a construction proof, so, or a construction proposition. So we need to construct it first, and then we need to prove that the construction is the required construction. So construct BEFG equal to triangle C, such that angle EBG equals angle D, and BE is in a straight line with AB, and all of that was from prop 42. Boom. Okay, so there's BEFG. We made it. All right. And then the next steps are kind of in typical Euclid fashion, written a little bit strangely, and I'll kind of do it a little bit differently. So he says, let FG be drawn through to H. So FG is up here, drawn through to H, which is going to be somewhere over here. Let AH be drawn through A parallel to either BG or EF. So that's how Euclid states it. The way that I would state it is kind of two pieces. One, extend FG in the direction of A. So that would just be what one of the postulates, postulate 2. And then the second piece would be to construct line L through A such that L is parallel to, I'll say, either one, BG or EF. They're parallel. They're both parallel, so it doesn't matter. Construct the line through, and then H is going to be the intersection of those lines. So I guess, let's see, which proposition was it? Prop 31 that allows us to make these parallel lines. Okay, so FG, I'm just going to extend that in the direction of A. And I think what I'll do is, for now, just because I don't know exactly where these will intersect, I'll make this a dashed line through here. And then I'll make this dashed line, so that was just extending FG. And then now I'll extend, or I'll construct this line L that passes through A and is parallel to BG. And I'll just kind of eyeball it. That looks roughly parallel to me. So we'll say about like this, yeah? Maybe a little bit further over. That's about good. Yeah, nice. There it is. And I'll make this a little bit more solid too. Yep. And then this intersection point here we'll call H. So I'll say let H be equal to the intersection of L with FG. Okay, so there's our H. Yes, great. Okay, join HB. So, and again, that's just postulate 1, no biggie. It's like kiddo stuff at this point for us. There's HB. It's the diameter of that little parallelogram. And then the next step is, let's see, I'll read what Euclid said, and then I'll see if I can kind of paraphrase in a good way. He says, then, since the straight line HF falls upon the parallels AH and EF, it follows from proposition 29 that the angles AHF and HFE together make two right angles. So I'll just say by prop 29, we have angle AHF plus angle HFE equals two right angles. And then he goes on and he says, therefore, the angles BHG, GFE are less than two right angles, and straight lines produced indefinitely from angles less than two right angles meet, which is what postulate 5 says. So maybe I might write it as then angle, all right, I'll use what he used, BHG plus angle GFE is less than two rights. And the reasoning there is because, well, BHG is less than AHF, since angle BHG is less than angle AHF, and kind of sneaky, GFE is the exact same as HFE. So that's where kind of this inequality comes from. And then postulate 5 is, just got to move this a little bit. Postulate 5, it follows then that HB and FE intersect. When extended. Or what did he say? Produced, right? Yeah, produced. Extended. Okay. And we say let them meet at K. So we need to extend these two lines, HB, which is this diameter, and FE, which is this right-hand side of the larger parallelogram that we're looking at. So again, I'll just start and make this maybe like a dashed line. Get an idea, it shouldn't come too much further down than that. And then HB, I'll just extend this like usual. Right there. Okay, perfect. All right, so yeah, it's kind of, this one's kind of an involved construction. It's not quite as straightforward and fast as some of the others were. Right, and I need a little bit of extra room because we're also not done. So I think what I'll do is, I'll do this. Just kind of, so, right, this is our point K that we just found. Yes, so there's K. Next, what do we do? Through the point K, let KL be drawn to either parallel to either EA or FH. So we'll say let's see, what did he call it? KL. So I'll give it a new name. I'll call it J, because L is going to be like an intersection point with HA over here. So construct J through through K. KL is drawn. Okay, so through K, such that J is parallel to FH or EA, whichever you prefer. And again, that was prop 31. So I just kind of like, my video is starting to lag a little bit because my computer is getting hot. And this through here, and I'll make it dotted just for now. So there's that one. And then what's the next piece say? And let HAGB be produced to points L and M. So HA and GB both need to be extended out. All right. And where they intersect with J, those are the points that will become L and M. Okay. There we go. So, yep, constructed J, and I'll say, all right, there's J, let HA gets extended to L. So L is J intersect HA, and M is J intersect GB. So L is right here. M is right here. Then HL KF is a parallelogram. HK is its diameter. And let's see, he says AG and ME are also parallelograms, but kind of maybe more to the point. LB and BF are complements. About HK. So remember, complements mean like if you have some larger parallelogram with a diameter, then that diameter kind of cuts off these two parallelograms on sort of either side that are sort of being extended off of the diameter. Those are called complements. And in particular, we had a proposition, which was Prop 43, that said that the complements are equal to each other. So by Prop 43, LB, which is, again, it's just a shorthand for ALMB, it's this bottom parallelogram, LB is equal to BF. Right? But BF was constructed equal to triangle C. So LB has the same area as triangle C. All right, and notice that LB has AB as one of its sides. LB is equal in area to triangle C. What was the only other requirement that we needed is that LB needs to be constructed inside of angle D. Where do we have that? This is maybe my favorite part of this proof because it's so clever. We didn't actually construct this angle right here. We constructed this angle. We constructed EBG, but EBG is an alternate angle to ABM, which means that they're the same angle. So we kind of like shoehorned that angle D into our construction. Right. So, and since angle GBE equals angle D, and angle GBE is alternate to angle ABM by prop, which one was it, 15? Yeah, by prop 15, we have that angle ABM equals angle GBE. So, oops, it equals angle D. Are we still on the screen? Yeah. Okay. So, LB is the required parallelogram. Wow. That is a cool proof. That is a big one. It's not super easy, and it's really clever, I think, because again, with those alternate angles, it's not the most direct way of doing it, but it does it. So, as usual, Euclid was just super clever, or whoever it was that actually made this proof, because chances are good it wasn't actually Euclid. He just compiled it. All right, there it is, QEF.